All right, here we're going to walk through our notes and look at really graphing these radical functions. Okay, so this is for 5.3. So we always want to start with our learning targets, right? So here's our learning target sheet, and we're really focusing on these two today. I can graph radical functions using transformations, and I can write the transformations of those radical functions. So the sheets that you're going to need look kind of like this, and they didn't copy super awesome this time, so we're going to have to fix them. So you'll see on one it kind of says parent function, and if you flip them over you'll see a couple of other ones. So we've got a parent function, right? And we're just going to go ahead and write these. And this can happen on both sets. We're going to be using both of them today. So parent function, because we always start with the parent function. Remember, that's just the function when nothing's being done to it, and then other stuff happens to it. Okay? And so I'm going to just hold mine kind of like this, and you'll see where we're going from here pretty soon. So I've got a parent function. I've got a horizontal translation. And remember, translation means I'm just shifting it. So horizontal translation means I'm just shifting my graph left or right. Then I've got a vertical translation. And again, you need to do this on both sets of these papers. So then when I flip this over, I see I have a reflection. Then I have a horizontal, stretch or shrink. And then I have a vertical, stretch or shrink. Okay, so once that's done on both of these sets, here's how we fold to make a little flip book. Okay, so I see I start with my parent function, and I leave it so I can see all of the titles that I'm looking at. So then I just fold this under so I can see all of them. So my next little thing, I would see reflection. I'm going to go ahead and crease that, and what you should do is put like one little staple, maybe two staples in here. If you don't have a stapler, that's fine. Just come find me and we can do that when you're back on campus. So once you have your two little books, we're going to look at the two different types of functions for this unit. Okay, so first off, we're going to look at the square root function. Okay, when we're dealing with the square root function, we also are looking at domain and range. Okay, so my parent function looks just like this. So we're dealing with the square root of x. And I should mention too that now is a great time to get some colors. You actually need to use color today to differentiate between our graphs. So if you need to, go ahead and pause the video and go find yourself some colors to use. Okay. So, but for this parent function, I see that my domain, and remember that domain is my x values. My domain starts here at 0 because I'm not touching the graph, I'm not touching the graph, and then all of a sudden right at 0 and going positive is the domain. So that's where this domain comes from. My range for my parent function is also y is greater than 0 because when I start down here, I'm not touching my graph at all, and then I start to, and it continues on and on forever. So now let's look at a horizontal translation and what that really means. Okay, so mathematically, it looks like f of x minus h in parentheses. That h tells me how far left or right I go. Big thing to note is always x minus h. Okay, so it's kind of going to be a little backwards for a little while. So here's the example that I'm using. So g of x, the g just tells me it's a different function, equals the square root of x minus 2. Well, so that x minus 2 tells me I go to the right 2 spaces. So you'll look at my graph. Okay, and we always start with our parent function. So your parent function is always going to be the same color, and then your other graph, your new graph, will be the new color. Okay, so my graph has literally just shifted to the right. It's only changed my domain to be x is greater than or equal to 2. My range has stayed the same because it didn't shift up or down at all. So we're really going to look at some of those and how you can tell where these numbers come from. Okay, so next one is a vertical, so up and down translation. So here we have f of x, and the parentheses are done, plus k. So anything vertical up or down is outside the parentheses. Okay, so this k is outside the parentheses, so that tells me it goes up or down. Okay, so here's my example. G of x equals square root of x, and then outside of that radical, minus 3. So my graph has literally just shifted down 3 spaces. So again, my domain has not changed, right? Because nothing went left or right. It only went down 3 spaces. So my range has then changed to y is greater than or equal to that negative 3. So let's look at a reflection, right? There's two possible reflections. I can reflect over the y-axis, or I can reflect over the x-axis. And that's where I'm using two different colors here. So if I'm reflecting over the y-axis, right, that's going across, it's going to be inside the parentheses. if I'm reflecting up and down, it's outside the parentheses. Okay, so you can see kind of where those negatives are. And I didn't add any numbers, right, because we're just looking at the reflection. So the only thing that really changes is the direction of your arrows for your domain and range. And you can always graph these to kind of look at where you're at. So here we can see that the reflection over the y-axis, right, changes my domain. So my domain is now little teeny numbers, so it's less than 0. Flipping it over my x-axis changes my range. Okay, so we can see some examples there. So now let's look at the stretching and shrinking. So here's where I'm going to multiply. Okay, so, and this is our horizontal stretching and shrinking, so it's inside the parentheses. That A value tells us what we're looking at. Okay, so here if I have a 3 inside there, that's really a shrink. If I have a 1/2, it's a stretch by a factor of 2. So it's kind of backwards when we're dealing with our horizontal stretch and shrink. And here's what it looks like. And whenever you're like, I'm not really sure, is this a stretch or a shrink or what? How can I graph it? Always go ahead and open Desmos and make put your graphs in. Okay, so now we're going to look at a vertical stretch or shrink. So here, since it's vertical, you can see it's outside the parentheses. And here it's like, since it's outside the parentheses, it is a stretch by a factor of 4. Since it's a fraction, it is a shrink by a factor of 1/5. And here's what those graphs would look like. Okay, so again, graph it in Desmos and try and help you understand what's actually happening here. So that's our square root function. Okay, the other function that we're dealing with in this chapter is the cube root, right? So I'm taking the cube root of x. So the cube root of x, my domain and range is all real numbers, because you can see it goes on in both directions, x, y's for ever and ever, and then it goes up and down forever and ever as well. So my domain and range are all real numbers. So that's what the parent function looks like. And then we're going to do these same transformations to the cube root function. Okay, so the first one is that horizontal translation, and again it's inside my parentheses and it tells me left or right. So here's my example that we're using. Again, my domain and range don't change for the cube root function, which is kind of handy. But you can see that my graph has just shifted 2 units to the right. So then a vertical translation. It's up or down and it's outside the parentheses. So here we can see that it's going down out the whole thing. Let's look at a reflection. Okay, again, we have our 2 different types of reflections. We can reflect in the y-axis and we can reflect in the x-axis. For this parent function, they look the same. However, they won't always when we're doing other things. But you'll notice the domain and range stay the same. The domain and range for a cube root function is always going to be all real numbers. So take a minute to get these figured out and look at our graphs and what they're doing. Then we've got our horizontal stretch and shrink, just like we did with the square root function. And we graphed those as well. And then we have our vertical stretch and shrink, just like we did with the cube root or the square root function. And we can look at what those look like as well. So now what your goal is to finish up this chapter, this section, is you need to have both of these flip books kind of completed. If you want to put them on the same page, you absolutely can. Mine, I just did a little while ago, but you could put them both on the same page and kind of be able to compare them easily, which would be kind of cool. So now what you're going to do is take this information to help you graph some functions, but then you're also going to look at these and say, okay, this has been done. What happened? How can I write the equation from a graph that you're given? Okay, so this is everything from 5.3, except graphing parabolas and circles. Okay, they in the book give you a fancy way to kind of do it mathematically, but what we're going to live in, we're just going to go ahead and use Desmos. So if you see in there that you're graphing a parabola or a circle, go ahead and use Desmos to help you do that and to kind of figure out what's going where. So as always, when you get stuck, go ahead and let me know when you've got questions.